Verify 1 over 1 minus sine square x equals 1 plus tan square x. Now we start on the left side. So let's write down. The left side is 1 over 1 minus sine square x. Now there are some simple trig identities that you should know. In the first box, we wrote tan, cosecant, secant and cot in terms of just sines and cosines. So if you look at the right side, you don't see anything other than sine and cosine. And then we can express sine and cosine with the Pythagorean identity. Sine square plus cos square equals 1. So this is the minimum that everyone should remember. If you know more Pythagorean identities, then you're pretty much done. See, 1 plus tan square equals secant square. So if you look at the right side, then if you can show that this is secant square, we are basically done. Alright, but let's assume that we don't remember this identity. All we know is what's in this box and this box. So 1 minus sine square x, that's going to be cos square x. So I'm going to write this as 1 over cos square x. Alright, so I started on the left and arrived here. Now on the right side, I can rewrite this as 1 plus sine square x over cos square x. And then I can see 1 as 1 over 1. And one other prerequisite is to know how to quickly add and subtract two fractions. So if you want to add two fractions, you simply cross multiply AD plus BC to get the numerator, and your denominator is the product of the denominators. If it's subtraction, you would have AD minus BC over BD. So in this case, if I want to combine 1 plus this fraction, I can think of 1 also as a fraction, 1 over 1. And then I can combine these two by cross multiplying to get the numerator. 1 times cos square x is just cos square x, plus 1 times sine square x is sine square x, over the denominator is 1 times cos square x, which is cos square x. And assuming that you remember cos square x plus sine square x is 1, what we have is the numerator is 1 over cos square x. Now notice that we simplified the left side to this 1 over cos square x, and the right side also simplified to that, which means what we have just shown is that the left side is equal to the right side, which means we are done.